Einstein famously said that the most incomprehensible thing about the universe is that it's comprehensible. We could easily imagine laws of physics that are complex, impenetrable, that could never be understood by a human brain, which is effectively 1.5 kilograms of jelly and water. And yet they are comprehensible. In fact, the universe is so comprehensible that a man of the 17th century, whose father had to sign his name with an X, Isaac Newton, was able to discern a universal law. That is, a law that applies at all times and in all places. And of course, that is the universal law of gravitation. Now, the British cosmologist Edward Harrison speculated on why the universe was comprehensible. He pointed to the fact that we know how to create a universe. So a universe began, we believe, in an extremely unusual state of the vacuum, extremely high energy, high density state known as inflation. And all matter, space, time, energy arose from this state. And inflation has often been called the ultimate free lunch because it did generate all that we see around us today. So Harrison said, well, if we know how to create a universe, all it would require would be to recreate this condition of inflation and we could create another universe. Obviously, this is way, way beyond our capabilities, but Harrison wondered, would it be beyond the capabilities of a super civilization that were maybe millions or even billions of years ahead of us? Maybe they would do this universe creating experiment just to see what the outcome would be. Now, if only one civilization in each of the 2 trillion galaxies in our observable universe did this experiment at one time in their existence, that would create 2 trillion baby universes. And maybe in those universes, there'd be creatures or super civilizations which would do the same experiment, spawning more and more of these baby universes. And the reason that the universe is comprehensible and the laws of physics are penetrable would then be because our universe was created not by a superior being, not by a god, but by supreme beings, beings essentially like us, but far more advanced. Given that the laws of physics had to be understandable by them for them to manipulate their universe, that would imply that the universe, the laws in our physics would also be understandable. One of the strange things about the universe is that the laws of physics appear to be mathematical. This is an extraordinary realization because it turns out that the universe has a twin. There is the universe that we can write down on a blackboard or a whiteboard in terms of mathematical formulae, and it has a complete analog in the real universe. And this is so extraordinary that it's been remarked upon by physicists for a long time. In fact, Galileo was the first person to realize that the universe was mathematical. And in 1960, the Austrian physicist Eugen Wigner wrote a famous paper called On the Unreasonable Effectiveness of Mathematics in the Natural Sciences. Why is it so effective? It's so incredibly effective that we can write down a formula on a blackboard that predicts the existence of, for instance, a black hole or the Higgs particle. And then when people actually go out and look in the real universe, they find these entities. So in a case of the Higgs particle, Peter Higgs was camping in the Cairngorm Mountains of Scotland in about 1965. And he came up with the idea that the universe should contain this particle known as the Higgs particle. 4 decades later, at a cost of 5 billion euros, it pops up at the Large Hadron Collider at CERN. This is an extraordinary fact. And Steven Weinberg, a physicist, has remarked that the problem that physicists have is not in taking their mathematical theories too seriously, but in not taking them seriously enough. So why is the universe mathematical? Why can it be understood using mathematics? Well, the Swedish American physicist Max Tegmark simply says that maybe mathematics is physics. Maybe mathematics is implemented as physics. And he imagines a multiverse of universes in each of which there is a different system of mathematics. So in some of the universes, the mathematics is simply flat paper geometry or Boolean algebra or something like that. And in these universes, the mathematics is not complex enough to generate stars and galaxies and intelligent life like humans. But in some of these universes, or in one of these universes, the mathematics is what we call a theory of everything. And that is complex enough to generate everything we see around us. Now, this is quite an extreme view. And the British physicist Stephen Wolfram, who's a billionaire, he became a billionaire from the creation of the computer language Mathematica. He's originally from London, but he lives in America. He believes that mathematics is not unreasonably effective at describing the physical world or the natural world. It just appears to be. He thinks that, imagine a drunk who looks for their dropped car keys at night and they look under a street lamp. And they look under the street lamp because basically that's the only place that they can possibly look. And he believes that mathematics, or Wolfram believes that mathematics is very similar, and it only illuminates the bit of the universe that mathematics can illuminate. But what most of the universe is doing is something entirely different. And in the early 1980s, about 84, Wolfram bought one of the first IBM PCs, and he made a discovery. And the discovery was that very simple computer programs can generate infinitely complex output if the input is, or the output is constantly fed back as the input. Now, before that, we thought that complex computer programs would produce complex outputs and simple computer programs would produce simple outputs. Now, here was a case he discovered in about 84 of incredibly simple computer programs that output infinitely complex outputs. And he wondered, is this what nature is doing? Is it using simple computer programs to generate everything from a rose to a galaxy to a newborn baby? Is that nature's secret? And in Wolfram's view, what most of the universe is doing is computing. And the only way to find the outcome of that computing is to run the computer program. So in that case, the only way to find out what the outcome of the cosmic computer program is today is to run the computer program for 14 billion years, the age of the universe. But within this cosmic computation, Wolfram thinks there are little islands where a shortcut is possible, where it's possible to know the outcome, predict the future outcome without actually running the computer program. And this, he thinks, these islands are what we call mathematical physics. I mean, it's an extraordinary idea, and I think Douglas Adams would really approve of it, given that in the Hitchhiker's Guide to the Galaxy, the Earth turned out to be a computer run by mice to find the answer to the ultimate question.